Math 3, Unit 9, Section 1. So today we're going to get into a little bit more of volume and different figures for volumes, and actually we're going to be cutting shapes in half and or taking pieces of them off and seeing what volume's remaining. So you guys already have your volume formulas, but here they are again at the top of this sheet in case you need them. So starting with example A, when you are finding volume, we kind of talked about this, but whatever shape names a figure, that's what you want to take the area of first. And so in this case, what would end up naming this figure? Yeah, it's a triangular prism. So we would want to take the area of the triangle first and then multiply by the height or the length that is left. And so in this figure, you can see here that this right here, if you were to take this out and draw this triangle outside of the figure, you have a 4 here and a 5 here. When you're finding the area of a triangle, we need our what two values? Base and height, exactly. And so here we are missing this base value. And so do you guys know what it is?
3 feet.
It is 3. If you remember, there's a 3, 4, 5 triangle. If you didn't remember that, we would just label this as like X, and you would use the Pythagorean theorem. And so I'll just go through and show you how that still gives you 3 as well. So x squared plus 4 squared equals 5 squared. X squared plus 16 equals 25. We subtract 16 to both sides. X squared equals 9, which means that x equals 3. Okay. So in order to find the area of my triangle here, we would go 3 times 4 divided by 2. So that's my base area. And then we have to multiply that by the height, which would be 6. Good. And so 3 times 4 makes 12, and we have 12 divided by 2, which is 6, and 6 times 6 makes 36, and we want to always measure and put our measurements, and so because we're taking volume, that would be what? Feet cubed is correct. Okay, B. How would we name this figure? Good. So it'd be like a trapezoidal prism. So that means what do we need to take the area first? The base. And so my formula again is volume equals our base area times the height. So my base area for this one, remember with the trapezoid, we have to take the 2 bases. And so the base that's here is 8.1. So my 2 bases, we're going to take the average. So we're going to add 8.1 plus 2.8, and we divide that by 2. Okay, and then we multiply that by what is the height of the trapezoid? Do we see?
3.
Very good. It is 3. Do you guys see how over here it's telling you 3? So times 3. Now that, bless you, is just my base area. And then what would be the height or the length? What is the other measurement that's making this 3-dimensional?
12.
Good. And so this is my big base. This is my base area because we have to take the average of the 2 bases times the height for my trapezoid, and then the height or length of the figure that makes it your prism. Okay, and so 8 plus 1 plus 2.8, that adds to be? 10.9. Good, and then 10.9 divided by 2 is?
5.
Good, 5.45 times 3. And then we're going to multiply that by 12. And so if you put all that into your calculator, what do you end up getting? Well, this one is 16.35 when you multiply it. And then multiply that by 12, and you get 196.2. Now this one, I don't see any measurements on here, so what would we write?
Units cubed.
Very good. Units cubed. Okay, questions there? Oh, you can turn it in the bin. Okay, moving on to C. We ready? Okay, so this is a what? Cylinder. And so what would be my base area on this one? Very good. It's a circle. So again, volume, we're going to do base area times our height. And in this case, my base area would be the area of a circle. They've given me my diameter. And so if my diameter is 15, that means my radius is going to be...
7.5.
You guys are so intelligent. Okay, so base area, you guys said was a circle, pi r squared. So that's pi. We have r, which is 7.5 squared. So that's my base area. And then we multiply by our height, which is... Very good. Okay, so in your calculator, 7.5 squared, you end up getting...
56.25.
Very nice. 56.25 is correct. And we take that, multiply by 32, and we get 1,800 pi centimeters cubed. Okay, good. There we go. And we're just going to leave these in terms of pi. Could you multiply by 3.14? Yes.
I would do.
Exactly. So just depending, if you had a multiple choice test and it said in pi, then you'd leave it like this. If not, then you just multiply that answer by 3.14. All right, any questions? Okay, moving on to D. Volume of a cone. So cones and pyramids are 1/3 of the area, and so this volume formula is 1/3 times my base area times the height. Okay, and so what is my base of this? It is a circle. So therefore we will,
Pi r squared.
very good. So we have pi, and then r will be what?
Half of 13.
Half of 13, which is
6.5.
6.5. So 6.5 squared, and then the height is
10.
10. Okay, when you're dealing with this problem, you always want to do your square part first. So 6.5 squared is what?
42.25.
Very good. So 42.25, and then we still have times 10. And so I might even, my calculator, you have 42.25, you multiply that by 10, you get 422.5, and then divide it by 3. And what do you get?
140.83.
That is correct. So we're just going to go 140.83 pi centimeters cubed. Okay, now in E, and just so you know, D and E end up going together. E says, find the volume of the truncated cone, which was created by the right circular cone in part D with a height of 5. So they're saying right here, this H is 5. Okay, so they've taken this cone right here, and they've cut off the top, and they want to know, well, what's left? What do you think we could do in order to figure that out?
We could find the area of the top little part and subtract it.
Exactly. So I'm not sure how to find the volume here, okay? But I do know how to find the volume of the cone. And the piece that is taken off is also a cone. Do you guys agree with that? The part that's been sliced and taken off. So if we are able to find the volume of the cone that was cut off, we can take this one and subtract it from the other. Make sense? Okay, so if I were to like kind of draw a little picture here, which I know I'm really good at drawing these things. Since they said that this is 5, do you know what the height is of this piece that they cut off? So remember, if you're comparing the two cones, do we know the height of our original cone?
10.
Yeah.
10. And we know this height is
5.
5. So in order to get the piece that was cut off in terms of the heights, what would you do?
Subtract it.
Exactly. You would take your 10 here. So for our heights, I'm going to go 10 minus 5. So I'm going 10 from the top and then 5 from here to get the piece of the cone that was cut off, which ends up being 5. Ah. Okay, so we know this is 5. Now, in terms of the radius, I'm not sure. And so back in 9.0, we talked a little bit about ratios. These are similar cones. These are basically the same cones, and so we can set them up as a ratio. And so this cone, the height is 5. Over this cone, the height is 10. Okay? Equals. We know this radius, correct? And so where would I put, for finding the radius, where would I put the 6.5?
On the bottom.
Very good. We put 6.5 on the bottom because the 6.5 radius goes with the 10 height. And then do I know what the radius is for the 5 height? No. And so we can just put R or X or whatever you want to do. I'm going to put R since that's what we're actually solving for, is the R. And so how would I end up solving this? Cross multiply. Okay? And so in your calculators, you can type 5 times 6.5. And we have 10R equals, good, 32.5. And then to solve for R, we divide by 10 to both sides. And we find that R equals,
3.25.
good, 3.25. And when you're dividing by 10, you can really just move that decimal one place to the left, right? Okay, so my R is 3.25. So now that I know that, that is that value right there, can I find the volume of that little cone? Yeah. So we have volume equals 1/3, and we need our base area, which is pi r, which is 3.25 squared, times the height, which in this case is 5. Good. So in your calculator, 3.25 squared you get like 10.5625. I end up leaving that value in my calculator. And so then I would just put times 5 and then divided by 3. And what do you get?
17.60.
17.60. Okay. And then that's pi, right? 17.60 pi centimeters cubed. Good. And so what's going to be our last step now? Bless you.
Do you subtract from the original volume?
Exactly. So we are just going to take my original cone, which is 140.83 pi, and we subtract 17.60 pi. And when we do that, what are we left with?
Oh, 230.
123 point what?
230.
Maybe that's right. Do you guys agree?
That's my guy.
0.23? Wait, 0.2, yeah?
Yeah.
123.23? Okay, 0.23 pi. And then that is still centimeters cubed. Okay, do we have questions on that? Okay, so now we're going to do the same thing, but we're going to do this next one with a pyramid. Okay, so we always start by finding the volume of the original pyramid or original shape that you have. So the formula for the volume of a pyramid is 1/3 base area times height. Very good. What would be my base area on this?
6 times 6.
Very good. And how did you know this other side was 6?
This is the square pyramid.
You guys are so intelligent. So when something's a square, that means all sides are equal, right? And so that means we're going to have 1/3, and my base area is going to be 6 times 6. And then, do I know what the height of this is? No, but we can figure it out, right? Okay. So we need to find the height. And so if I draw a triangle here, I don't know what the height is right here, x. Do I know how much this piece of this triangle is?
3.
3. It's half of it, right? Because we're taking a point from the middle, from the vertex, and so I'm cutting that in half, so it's 3. So if I use my Pythagorean theorem, we have x squared plus 3 squared equals 10 squared. We get x squared plus, what's 3 squared? 9 equals, good. We subtract 9 from both sides. We get x squared equals 91. We take the square root of both sides, and I get x equals 9.5. So that means this is going to be times 9.5. Do we have any questions on any of that so far? We're good? It's up to you and how you do this here. On this one, I noticed that 3 will divide evenly into 6. So I sometimes like to reduce it just so that I have less work to like type in. And so I know that 3 goes into 6 2 times. And so now I'm just going to take 2 times 6 times 9.5. And we get what? $114 meters cubed. Okay, so there is my volume of my original pyramid. Okay, so G says find the volume of the truncated pyramid, which was created by the pyramid in part F. So again, I'm just gonna kind of mark these. These two questions are going together so that you understand that when you look back at your notes. Which was created by the pyramid in part F, where H, this time, is 4. Okay, so again, the part that's cut off, can we find what that is? Yeah, we know it's a square pyramid. Very good. So when we're finding the volume of our smaller cut off pyramid, I'm going to try to not draw a picture this time. We're going to have to take, we want, you know, I'm just going to kind of draw this right here. Okay, you guys get it. If this height is 4, what's the height of the piece that was cut off?
2.
5.5. Where did I get that 5.5 from?
Because you subtracted that height from the original height.
Right, we found our original height was 9.5, right? And so we're going 9.5 from my original height. They told me this height on this figure was 4, so 9.5 minus 4 gives me a height of 5.5 of what was chopped off. Okay, so now we need to find, well, what is my base, right? We need to find out what is that length, and then we could double it to find like the actual base length. Do you guys agree? Okay, so what am I going to do? So we need to set up a proportion. Okay, look back at what we did on the cone. Okay, so if we go back and look at what we did on the cone in order to find that radius there, we knew that the smaller height we found was 5 over the bigger height was 10. So we knew both of those. We had found our heights. And then we're like, okay, well, we know the radius on the big one is 6.5, and so we put R for the smaller one, right? So this is the same idea on this one. Do we know the bigger height?
9.5.
Good. And so if I'm writing a proportion, it doesn't matter where you put it, but I'm going to go 9.5 on the bottom. It could go on the top, it doesn't really matter. And in relation, what is the smaller one for the height? 5.5. Okay? Now on the base, and it's up to you, we could actually use the whole base if you want to, or we could use half, but why don't we just use the whole base? Is that okay? So the whole base on the larger figure is 6, that length. So would that go on the bottom or the top? Bottom, because it needs to match with where the big number is, right? So this will be 6, and then you can use whatever your variable you want. I'm going to use an x this time. So right now I'm trying to find this whole length right here on this pyramid. Okay? So what do I do? Good. So, good. Thank you. 9.5x equals 33. And then in order to solve, we, good, divide by 9.5. And we get 3.47. Okay, and so this whole length right here is 3.47. So when we're taking our volume, we're going to have 1/3. My base area is going to be 3.47 times 3.47. And then we know the height, which is,
5.5.
very good. So in your calculators, we're going to go 3.47 times 3.47. We get 12.04. Can you multiply that? And then I'm going to take that answer and multiply it by 5.5 and then divide that by 3. And so the volume we end up getting is 22.07. And then that would be what? Meters cubed. Now, is that my answer? No. What do I need to do? Very good. And so we're going to take the original pyramid, which was 114, and we subtract the 22.07 from it because that's what was cut off. And we get what? Good. 91.93, and that is meters cubed. Okay, do we have any questions before moving on? No?
Where does the 114
Our original, the big figure.
Oh, okay.
That's where the 5.5.
Oh, is it?
Okay, any other questions?
Okay.
Serena, do you have a question? Did I write something wrong?
What do you get 33 from?
Where's my 33?
9.5x equals 33. Cross multiply. Oh, cross multiply.
5.5 times 6. So I cross multiplied here and here to get 9.5x equals 33, and then divided by 9.5 to both sides. Okay, anything else? No? All right. Okay, so this next one, it says use the given information to find the missing dimensions. So they're telling you that the volume of this square pyramid is that answer, 1,568, okay? They're telling you that the height of it is 24. They want you to find the slant height, okay? So I would start with, we know how to find the volume of a pyramid, correct? And so I'm just gonna write the formula to start with. Volume equals 1/3 base area times height. Okay? They have told us, so I'm going to start plugging things in, okay? They have told us the volume is this. So that means I have 1568 or 1,568 equals 1/3. Now, my base, they told me it is a square. And so I'm going to label that as multiplying base times base because they're both going to be the same values. Are you guys okay with that? So my base area would be base times base, and you could label this as a B if you want to. You could use any variable. And then my height is what?
24.
Good, times 24. Okay, so now we want to basically, could I solve for B? Yeah, because it's the same variable. It's not like I have two variables in the same equation. So I'm going to simplify this a little bit. I have 1568 equals 24 times 1/3. That really is 24 divided by 3, which is what? 8. So I have 8b squared. And what would I do next in order to solve for b? Good. Divide by 8 to both sides. When you divide there, you get 196 equals b squared. And what would be your last step? Good. Take the square root of both sides. And so when you do that, b equals 14. Okay, so that means that my base is 14. Is that the question that they asked me though?
No.
No. How can I find that slant height?
Pythagorean theorem.
Very good, Pythagorean theorem. And so if I were to draw a line here, this is like the triangle that we're looking at in there. And so therefore, what would be the base of this triangle? 7, good, because it's this height is cutting this in half, right? So it's 7 and 7 on each side, and then we can find our slant height. So when I set this up, is that an A or a B or a C for the slant height? Good. So we're going to have 7 squared plus 14 squared, or sorry, 24 squared equals C squared. 7 squared is 49, plus 24 squared is 576 equals our C squared. We add those together and you get 625 equals C squared, and we take the square root of both sides, and C equals 25. So that means that my slant height is 25 what? Very good. All right, any questions there? No? Okay. Next one. Use the given information to find the missing dimension again. So this time we have the volume of a cone. Okay, they've told us that the cone is this value. The radius of the lower base is 12 centimeters. So where is that? What are they talking about? Yeah, so this circle right here, this is 12 centimeters. Okay, and it wants to know what's the height of the original cone. If the height of the truncated cone is 15 centimeters, and then it wants to know what is the radius on the upper base of the truncated cone. Okay, so let's start with the volume of a cone and plug in and see if we have enough information to solve. So volume of a cone we know is 1/3 times our base area times the height. Okay, so they told us the volume is 1,680 pi equals 1/3. Now, do we know how to find the base area of this cone? How do you find that? Very good, pi r squared. So we have pi, and then r in this case is 12 squared, and then we don't know our height. Okay, one thing that's kind of nice is that when you have a pi on both sides of the equation, we could divide by pi on both sides, and they end up what? Canceling out. So instead of taking the time to actually divide them by both sides, I just cancel them out because I know they're going to cancel out. Okay, so then in your calculator, if you type in 12 squared is what? 144, and what's 144 divided by 3? 48 is correct. So I have 1,680 equals 48h. And then to solve for h, what will I do? Divide by 48 to both sides. And so h equals 35. Okay, so now I know that this height right here is 35. We also can write here the height of the original cone is 35 centimeters. So that was one of the questions that they asked. Okay, now we're trying to find the radius over here. Okay, so I'm going to go ahead and draw the rest of the cone in. Do we know what the height is on this one?
20.
Very good. How did you get 20?
Subtracted 30.
Good. The big one was 35. We subtracted out the truncated part that we know, 35 minus 15, means this height is 20. So just like we did on the other problems, could I set a proportion in order to solve for my radius is? Yes. Okay. So how am I going to set it up?
You're gonna do the smaller height.
Okay. Yeah. So, okay, we'll go a smaller one. So 20 over what? 35 equals, do we know what the smaller radius is? No. And so that's going to go on the top or the bottom of the next fraction. Good. And then the bottom or the denominator is going to be what? 12. Are we all good? Okay, so then we're just going to cross multiply. 35 times r is equals, and 20 times 12 is 240. And then we divide by 35 to both sides. And we find that R equals 6.9. So the radius of the upper truncated cone is 6.9 centimeters. Questions?
Do you have any Vaseline?
Okay, can we deal with this when we're done with those? Thanks. Okay. Last one, our last two here. We have a sphere. Find the volumes of each of these solids. So if you go back to your formulas, the volume of a sphere is 4/3 pi r cubed. So we're just plugging in numbers for this one because we have the entire sphere. So we have 4/3 pi, and then what's my radius? 5. So 5 cubed. Remember, order of operations, we'll always do exponents first. So 5 to the third power is
125.
125. Okay, and then I would go and multiply my two top numbers together. So 125 times 4 is 500 is correct. So I have 500 pi over 3. If you wanted to divide this and reduce, you could, but it doesn't go in evenly. And so I'm just going to leave it like that, and then we have yards cubed. Okay, same thing on this other one, except for what?
There's only half of it.
There's only half of it. So I'm going to set up the equation, but basically you're going to find the volume of the entire sphere and then divide by 2 at the end. Okay, and so volume is again 1/3 or 4/3, sorry, pi r cubed. So and then we're going to end up dividing that by 2 once I get the answer because it's only half of the sphere. Volume equals 4/3 pi. My r on this one is 9. So we have 9 cubed. So I'm just going to go through this here. So 9 cubed is 729. But do you know 3 will go into 729 evenly?
Yeah.
And so I'm just going to reduce that. So 3 goes into 729, 243.
Oh my gosh.
So we end up going 243 times 4, which is 972 pi. And so that's my volume of my sphere. But then we need to take that value and divide it by 2. And so we end up with 486 pi, and then it's what?
Units.
Units
Cubed.
what? Good. Units cubed. Any questions on this one?
Instead of writing out units, can we just write U?
Sure.